So good day, I am Naixel Pizarra. We're gonna discuss about radiation and propagation of waves. So let us talk about first the history of radiation and propagation of waves. According to some other books, James Clerk Maxwell was the first that talks about the radiation and propagation of waves. So he unified the electric and magnetic theory, also predicted electromagnetic wave propagation, theorized that light was an electromagnetic wave, and he also questioned that low frequency waves can be generated or not. Then Heinrich Hertz, he was the one who experimentally verified Maxwell's theory, generated and propagated radio waves, and he also was the one who built the first transmitter, antenna, and receiver apparatus. Then, let's go to Guglielmo Marconi. He was an inventor of radio. Came from the two inventors or scientists. He was inspired for their studies in improve and commercialize Hertz apparatus. He used the Hertz apparatus for radio telegraphy and one of the first radio engineers. So let us talk about radiation. Radiation is the emission and propagation of energy in the forms of waves or particles. It can travel through medium of vacuum. Radiation is also seen in the form of electromagnetic waves or particle. Some examples of these are sound, light, UV rays, X-rays, and etc. Propagation of waves. So, wave propagation is any waves that travels with respect to the direction of the oscillation relative to the propagation of direction. For some electromagnetic waves, propagation may occur in a vacuum as well as in a material medium. Other waves cannot propagate through a vacuum and need a transmission medium to exist. So some few concepts under radiation and propagation of waves are free space, which does not interfere with normal radiation and propagation. Point source, a simple point acting like a source, radiating in all directions. And power density, which is the power per unit area. Then next is the isotropic source, one which radiates uniformly in all directions. And polarization, determined by the direction of oscillation. So, for example, there is a vertical direction of oscillations. So, the polarizations of the electromagnetic field or the electromagnetic wave rather would be also in a vertical. Same also as the horizontal. So let us go to the optical properties. So optical properties simply means that it is the operating in the visible part of the electromagnetic spectrum or are relating to sight in relation to the action of light. So some of the optical properties of radio waves are refraction, which is bending, reflection, which is bouncing, diffraction, which is scattering, and interference, which is colliding, which will be discussed in the next slide. So here is the more specific discussion of the optical properties. So first is the refraction. It is the bending of radio wave path. It also actually changing of direction of an electromagnetic ray as it passes obliquely from one medium into another with difference. Then next is the occurs when a radio wave passes from one medium and into another medium of different density. So, as you can see, as we all know, that refraction is the bending of the radio wave path. So, reflection. Let's go to reflection. Reflection is to cast or to turn back. So, it is an act of reflecting. So, for example, this is the surface. The wave will reflect. Occurs when an incident wave strikes a boundary of two media and some or all of the incident power does not enter the second material. So, hindi siya pumapasok. So, nagbabounce lang siya. Ganon. And then, next is the diffraction. Spreads out or scattering. Redistribution of the energy within a waveform when it passes near the edge of an opaque object. A phenomenon that allows light or radio waves to propagate peak around corners. Then next is the interference or the opposition. Occurs when two or more electromagnetic waves combine in such a way that system performance is degraded. Subjects to the principles of linear superposition of electromagnetic waves and occur uh, whenever two or more waves simultaneously occupy in the same point in space. So we will use these optical properties of radio waves on the next lesson. So these are the modes of the propagation of waves. So first is the ground wave propagation. So it propagates from transmitter to receiver by gliding over the surface of the Earth, in which both antennas are close to the surface of the Earth. It follows the curvature of the Earth, and Earth is assumed to be an ideal conductor. Electromagnetic waves cannot penetrate ideal conductor, only exist in dielectric medium above conducting surface. That's why ground waves propagation is possible. Then the ground waves are transverse in nature. Horizontal polarized antennas are not preferred as the horizontal component of the electric field in contact with the Earth is short-circuited by the Earth. So basically, for example, this is the transmitting antenna. It will travel from the surface of the Earth. That is why it is called a ground wave propagation. Then it will go to the receiving antenna. So we have different modes of propagation nga. This is one of the first and maybe commonly used of other communicational businesses or corporation. So next is the skywave propagation. Skywaves are reflected from ionized layer of atmosphere back down to the Earth's surface, and it is useful for very long-range distant communication. Can travel a number of layers between ionosphere and Earth's surface, and also known as the ionospheric wave. Ionospheric wave kasi yun yung nasa layer ng ionosphere siya, so natatawag siyang ganong wave. And then, as you can see, for example, dito nagsimula yung antenna, then it will bounce yung wave niya dun sa ionosphere. It will bounce, then pababa. Papunta dun sa pupuntahan niyang magre-receive ng wave. So, ganun yung skywave propagation. So, katulad, di ba nga, yung ground wave, pababa, papunta sa ground, papunta sa receiver. Then, ito namang skywave, from the antenna location, papunta sa, yung wave niya papunta sa ionosphere, magta-travel from the Earth's surface to the ionosphere, then will go to the receiver. Then next is the space wave propagation, also known as line of sight. It is the mode of wave propagation. Electromagnetic waves, after transmitted from transmitting antenna, reaches the receiving antenna, either directly or after reflection from Earth's surface and tropospheric region. So, makikita nyo dito, transmit antenna. So, ito yung magta-transmit ng antenna, ng radio waves. So, diretso siya. Hindi na siya dadaan sa other kind of hindi na siya magbabounce or magdadaan sa other surface, kundi diretso na dun sa receive antenna. Kaya tinawag siyang line of sight. Ibig sabihin, isang direction lang. Ayun. So, that's all. Thank you for listening. I am Nexel Pizarra, and